You know what's scarier than artificial intelligence? Artificial intelligence that can rewrite itself without asking permission. It can identify its own weaknesses and fix them faster than humans can understand what changed. That improves exponentially, while we improve linearly. That just became real. Google DeepMind, an AI that uses reinforcement learning to create better learning algorithms. It's not waiting for human programmers anymore. It's improving itself. And according to a former OpenAI researcher who just released the analysis, we might have 3 to 5 years before this becomes irreversible, maybe less. So who figured this out, and why should you listen? Leopold Aschenbrenner, former OpenAI researcher, the guy who was inside the building when GPT-4 was being developed. He didn't just watch AI progress, he helped build it. Then he left, and wrote a report that's making every AI lab very, very nervous. The report's called Situational Awareness, and it's not about what AI can do today. It's about what happens when AI can improve AI. Here's the timeline he calculated. We go from GPT-4 to artificial general intelligence, human-level AI, by 2027, maybe sooner. That's the first jump. But here's the part that should terrify you. Once we have AGI, we have an intelligence that can do AI research, better and faster than humans. It will improve itself. And the jump from AGI to superintelligence, something vastly smarter than any human, won't take another decade. It might take months, maybe weeks. Think about the gap between a monkey and a human. That's the gap we're about to create between humans and AI. Except it's happening in our lifetime, in the next few years. And Leopold's math suggests we're not ready for it. Here's what Leopold figured out, and it's easier to understand than you'd think. Let's start with a story. In 2016, Google built an AI to play Go, an ancient board game way more complex than chess. They called it AlphaGo. First, they trained it by showing it the best human games ever played. It learned from human experts, got pretty good. Then Google did something different. They let AlphaGo play against itself, over and over, millions of games. And something crazy happened. It started making moves no human had ever thought of. Moves that looked stupid at first, until 10 moves later, when you realized it was genius. It had gone beyond human ability by learning from itself. That's the key insight. Once AI is good enough to learn from itself, it breaks past human limits. Now apply that to AI development itself. Right now, we have a few hundred really smart people working on making AI better. They're at companies like OpenAI, Google, and Anthropic. These researchers work normal human hours. They think at normal human speed, and they're making massive progress. That's why we went from GPT-2, which was pretty dumb, to GPT-4, which is scary good, in just 5 years. But here's where it gets wild. Once we have AI that's as smart as those researchers, we won't just have a few hundred. We'll have millions, and they won't work 40-hour weeks. They'll work 24/7. Let me break the numbers down in simple terms. Right now, the big AI companies have massive computer chips. Think of them as super powerful calculator chips. Leopold says by 2027, we'll have tens of millions of these chips. Each chip can run about as much thinking power as one human brain. So that's tens of millions of AI researchers, all as smart as the best human researchers, all working at the same time, all working on the same problem, making AI better. But wait, it gets worse. These AI researchers won't just be as fast as humans, they'll be faster, way faster. Leopold points to an AI called Gemini Flash that came out in 2024. It was 10 times faster than the previous version at solving problems, 10 times faster than the year before. A few hundred humans found a way to make AI 10 times faster in 1 year. Now imagine millions of AI researchers looking for the same kinds of improvements, working day and night, never sleeping, never taking breaks. Leopold's calculation? These automated researchers could work at 100 times human speed, maybe more. Now do the math. 100 million AI researchers, each one works 100 times faster than a human. That means a task that would take a human researcher a year, an AI researcher finishes it in about 3 days. And all of them are working on one thing, making themselves smarter. You see the problem? Once AI gets smart enough to improve itself, the improvements accelerate, fast. And the jump from smart as a human to way beyond any human might not take decades, It might take months. That's recursive self-improvement, and it's not science fiction. The math checks out. The technology exists, and it's happening right now. Still sounds too abstract? Leopold makes it concrete with a real example. There's a researcher at OpenAI named Alec Radford. Most people outside tech have never heard of him, but inside AI labs, he's legendary. He's the guy behind many of the biggest breakthroughs in the last few years, the innovations that made ChatGPT possible. Leopold asked other OpenAI researchers a simple question. If you had 10 copies of Alec Radford all working on the same problem, how much faster could you solve it? Their answer? 10 times faster. Easy. Okay, what about 100 copies of Alec Radford? What about 1,000? Now here's where it gets real. Imagine 1,000,000 copies of one of the world's best AI researchers all working together, all sharing discoveries instantly, all working 24/7 without sleep, and all working 10 times faster than a normal human. That's not a thought experiment. That's what becomes possible once we have human-level AI, because we can make as many copies as we have computing power to run. Leopold did the math on what this means. Right now, progress in AI happens at a certain speed. We had GPT-2 in 2019. It could barely write a coherent paragraph. By 2024, we will have GPT-4, which can write code, analyze data, and hold complex conversations. That jump took 5 years and hundreds of researchers working at human speed. Now imagine compressing that entire 5-year jump into less than a year. That's what millions of automated researchers could do. Take a breakthrough that should take a decade and finish it in months. But here's the terrifying part. That 5-year jump took us from barely coherent to pretty impressive. It was going from a preschooler's intelligence to a smart high schooler's intelligence. Now imagine making that same size jump, but starting from a human expert level instead of a preschooler level. You're not going from preschooler to high schooler. You're going from expert researcher to something we don't have words for, something far beyond any human capability. That's superintelligence, and Leopold's research shows it could happen within a year of reaching human-level AI. Not decades, not even years, 1 year. It's not just about quantity. Automated AI researchers will have 5 advantages humans simply cannot match. First, perfect memory. They can read every machine learning paper ever written, remember every experiment ever run, store it all perfectly. A human researcher might remember key points from 50 papers. An AI remembers millions. All the knowledge is instantly accessible. Second, no mistakes. They can write millions of lines of code and check every line for errors before running it. What takes human teams months to debug, AI does in days, perfectly. Third, instant copying. Train one AI researcher, copy it 1,000,000 times. No hiring, no training, no meetings. Just peak performance, all working simultaneously. Fourth, perfect communication. Human researchers write papers. Others read them weeks later, maybe misunderstand. AI researchers share knowledge instantly. One discovers something, and all of them know it immediately. Fifth, self-improvement. Once they exist, they make themselves smarter. Each improvement makes the next one faster. The smarter they get, the faster they improve. That's exponential growth. Put it together, millions of researchers with perfect memory, no mistakes, perfect coordination, and self-improvement. That's why Leopold says 1 year, and that's why we can't keep up. The biggest objection, computer chips. AI research needs them to run experiments. 1,000,000 researchers don't help if there aren't enough chips to run experiments, right? Leopold says this bottleneck won't slow things down as much as you'd think. Why? 4 reasons. 1. Most breakthroughs don't need massive scale. AI researchers test ideas small first, and small will soon mean GPT-5 level. That's enough for serious innovation. 2. AI prioritizes better. Humans waste time on tiny improvements. AI focuses only on major breakthroughs. 3. Efficiency improves fast. Costs are dropping 50 times every few years. That means 50 times more experiments with the same chips. 4. AI predicts better. Humans tried dozens of approaches. AI, with perfect memory of every past experiment, predicts what works before testing. Fewer wasted experiments. Even with limited chips, AI uses them 10 times more effectively than humans. That's enough for an intelligence explosion. But what about other things that could slow this down? Leopold addresses 3 main concerns. First concern, maybe AI can't do everything. Maybe AI can handle 90% of research tasks, but that last 10% requires humans. If humans remain necessary, progress stays slower. Leopold thinks this might delay things by a couple of years. Maybe 2026, 2027 AI models do most research, but still need human help. True full automation arrives around 2028. That would still mean superintelligence before 2030. Second concern, maybe there's a ceiling. Maybe AI simply can't get that much better. Maybe we're closer to the limit than we think. Leopold doubts it. His reasoning is simple. We achieved massive improvements in the last decade. There's no clear reason we can't achieve similar improvements in the next decade. Current AI systems are still primitive in many ways. Plenty of room for dramatic improvement. Third concern, maybe progress naturally slows down. In every field of science, the easy discoveries happen first. Then it gets harder to find breakthroughs. Like picking fruit from a tree, you get the low branches first, then progress slows. But Leopold points out the math here is overwhelming. We're going from hundreds of human researchers to potentially hundreds of millions of AI researchers. That's not just a bigger team, that's millions of times more research capacity. Even if each discovery gets harder to find, the sheer scale of that increase should overcome it. His conclusion? The most extreme scenarios, AI improving itself overnight, probably won't happen, but going from human-level AI to vastly superhuman AI within 1 to 3 years, that should now be considered the most likely outcome. So what does superintelligence actually mean? Not just smarter than humans, something fundamentally different. By the end of this decade, we could have hundreds of millions of powerful computer chips running billions of superintelligent AI systems. These systems would think orders of magnitude faster than humans, master any field in days, read every research paper ever written, and learn from billions of copies simultaneously. Think about that. One AI system gaining the equivalent of billions of human lifetimes of experience in just weeks. But the real difference isn't speed or knowledge, it's how it thinks. Remember AlphaGo's famous move against world champion Lee Sedol? A move so strange that expert commentators thought it was a mistake, until it won the game.
Ooh. That's a very surprising move.
I thought it was a mistake.
That was creativity emerging from a way of thinking no human could match. Superintelligence will do this across every domain. It'll find solutions too complex for us to understand even if it tried to explain them. It'll spot patterns and opportunities humans would never see. It'll solve problems that would take human researchers decades in hours. Leopold uses a good analogy: Minecraft speedrunners. Watch them beat the game in 20 seconds using glitches and exploits most players don't know exist. Now imagine that mindset applied to science, technology, medicine, engineering, everything. The progress explosion won't stay confined to AI research. It spreads to everything. Robotics gets solved first, because robotics is mostly a software problem now. Once superintelligent AI cracks it, factories transition from human-run to fully automated. Physical work becomes solved. Then scientific progress accelerates beyond comprehension. You can't just give Einstein a billion clones and expect them to revolutionize every field. Humans have limits. But a billion superintelligent researchers working 10 times faster than humans, they could compress a century of R&D into a few years. Think about the entire 20th century, from the Wright brothers to the moon landing, from basic electricity to computers, from horse-drawn carriages to ICBMs. All of that progress compressed into less than a decade. That's what Leopold predicts for the 2030s. The economic impact is staggering. Today, the economy grows 2 to 3% per year. Leopold predicts 30% per year or higher, possibly multiple doublings per year. Why? Because the labor constraint disappears. Right now, growth is limited by workers. You can build more factories, but you need people to run them. Fixed labor force means fixed growth. With AI and robots doing all labor, that limit vanishes. Robot factories build more robot factories. Self-replicating manufacturing with no bottleneck. Exponential expansion. This has historical precedent. For thousands of years, economic growth was zero. Then the Industrial Revolution jumped it to 2 to 3% annually. That transition changed civilization. Superintelligence triggers another transition, from 2 to 3% to potentially 30+%. From economies doubling every 15 years to doubling every year. Society will resist. Regulations, pushback against change. But in competitive domains like military production, we'd see explosive industrial growth. Throughout history, technological progress and military power have been inseparable, and Leopold argues superintelligence would be the biggest military advantage ever. Start with the obvious: drone swarms, robot armies, completely new types of weapons, laser-based missile defense that's essentially invulnerable, novel weapons of mass destruction. Compared to pre-superintelligence militaries, it would be like modern armies fighting a 19th century cavalry unit. Horses and bayonets against tanks and drones. Not even close. But here's what's more disturbing. Even without physical robots, even with just digital superintelligence, whoever controls it might have enough power to overthrow governments. Think about what a small group of superintelligent AI systems could do. Hack any undefended military system, any election infrastructure, any media network, persuade generals and voters with arguments so sophisticated we wouldn't recognize the manipulation, economically outcompete entire nations, design synthetic bioweapons and pay someone in Bitcoin to create them, coordinate thousands of simultaneous attacks while we're still trying to figure out what's happening. All of this without a single physical robot, just intelligence. Leopold uses a striking historical parallel: the 1500s. Hernán Cortés conquered the Aztec Empire, millions of people, with about 500 Spanish soldiers. Francisco Pizarro conquered the Inca Empire with roughly 300 men. Afonso de Albuquerque controlled the Indian Ocean with about 1,000 Portuguese. These weren't gods, they didn't have magic powers, but they had a technological edge and strategic advantage that proved utterly decisive. Small forces conquered empires. Superintelligence would be a far bigger advantage than the Spanish had over the Aztecs. Leopold's conclusion is stark. Whoever controls superintelligence could have enough power to overthrow the US government. That's not an exaggeration. That's a serious strategic assessment. And it's why the race to build superintelligence is also a race for global power. Leopold draws a parallel to the atomic bomb, and it should make us uncomfortable. In 1914, H.G. Wells wrote a novel predicting atomic bombs. Pure science fiction. In 1933, physicist Leo Szilard figured out how a nuclear chain reaction could work, but he couldn't convince anyone. Too theoretical. Too crazy. Then in 1938, nuclear fission was discovered. Suddenly it wasn't theoretical anymore. Szilard immediately saw the danger and argued for secrecy. He convinced Einstein, who agreed to sound the alarm, even though it might make him look foolish. But most scientists thought they were overreacting. Fermi and Bohr believed the conservative thing was to downplay the risk. A bomb sounded too extraordinary, too unlikely. Even though, as it turned out, a working atomic bomb was only 5 years away. We're at that moment again. Among senior scientists at leading AI labs, many see a rapid intelligence explosion as highly plausible. They understand the trajectory. They can see it coming. But the broader world, policymakers, most of tech, the public, still think it sounds like science fiction, yet the warnings keep mounting. Stuart Russell, who literally wrote the textbook on AI, believes we may only have 4 years left to get this right. John Tallon, co-founder of Skype and major AI safety funder, argued in 2023, the extinction risk from godlike AI is not just possible, but imminent now. The pattern repeats. Experts see the danger, most people dismiss it, and the technology keeps advancing. Superintelligence is possible, and the process has already begun. AI progress won't stop at human level. Millions of AGIs could soon accelerate research, compressing decades into a year and pushing us towards superintelligence. By decade's end, AI may control economies and militaries. Experts warn AGI could be just years away. The intelligence explosion has begun, and what happens next depends on us.